So let's take a look at your MT5 LT1 seminar, Angles of Triangles. Before you move on, do the first 5 questions. If you're doing this before class, we'll go over them in class. If you're doing it ahead or behind, I still do them to activate your prior knowledge. What we want to do today is we're going to do a proof of the triangle angle sum theorem, and we're going to apply that theorem to solve some problems. We're going to prove the exterior angle theorem and apply that to solve problems. We're going to prove the corollaries of the triangle angle sum theorem, and we're going to apply those corollaries to solve problems. In other words, we're going to do a lot of proofs today, at least on this lesson. Our first proof, the triangle angle sum theorem. You probably know this one without knowing the proof. And what it is we know no matter what kind of triangle we have, we know the sum is 180 degrees. Well, let's do the proof of that. So here's what we're going to do. I'm going to draw a triangle, any triangle, doesn't matter what it is. I'm going to label my angles 1, 2, and 3. I'm going to draw a line parallel to this line that goes through the vertex of my angle. I didn't draw that very well. Let me retry that. Okay. There we go. And then I'm going to move it down so it corresponds. Now, what that does, why can I do that? That's called your parallel postulate we talked about. We don't use it very often, but it says, hey, I can draw any line parallel to another line whenever I want. That's what we're doing. Now what happens, notice, it creates a couple other angles. I'm going to label them 4 and 5. Now because I have parallel lines, I have alternate interior angles. Angle 4 is congruent to angle 1. And angle 5, that's congruent to angle 2. We know because we have a straight line here, I know the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 equals 180. Why do I know that? Because that's how many degrees are in a straight line. And that's what we get here. Then I can substitute. Instead of saying angle 4, I'm going to say the measure of angle 1. I'm going to keep angle 3. And instead of saying angle 5, I'm going to say the measure of angle 2. So that is substitution, isn't it? So if we're doing the proof, I didn't make you do the formal proof, but we did kind of an informal proof of why this works. Now let's apply that to a problem. I want to find the measure of the numbered angles here. And I can do this a couple different ways. I'm going to start with angle 1. And I notice in angle 1 I've got a straight line. So the measure of angle 1 is going to be 180 minus 57. So if I take let's do that together. Let's take 180 minus 57. Well, that flash, that was kind of cool. 180 minus 57, and we get 123. So I know the measure of angle 1 is 123 degrees. I think I'm going to put that in my picture right here. So I know this is 123 degrees. Now to find the measure of angle 2, I know measure angle 2 is part of a triangle. So the measure of angle 2 is 180 minus 71 minus 57. because I know all three of my angles add to 180. So I'll just subtract those off. So I'll take 180 minus 71 minus 57. I already got the 57, so let's just minus 71. And notice I get 52 degrees. Whoa. There we go. Oop, that's going to disappear. 52 degrees. And I think I'll do the same thing for the measure of angle 3. The measure of angle 3 is 180 minus one of my other two angles, which are 128 and 123. So I'll say minus 28 minus 123. This one I think I'll do a new line for. So 180 minus 123 minus, what was it? It was 28. And we get 29 degrees. Now, if we look at the next part, we're going to be looking at interior versus exterior. Interior are angles on the inside. Exterior is angle on the outside. Now, we got to be a little bit more specific. It's when I extend one side out. Because if I extend two sides out, notice what happens here. Like I extend BC out, I get an exterior angle over here. We'll call that angle 5. And yes, angle 4 is congruent to angle 5. I also get angle 3. That is not exterior because it's formed by two intersecting lines. And on this one, angle 2 is congruent to angle 3. Both of those are true because they're vertical angles. So exterior is formed by one line, not two. You got to be careful of that when we apply that to a problem. Okay, and then a remote interior angle. I'm going to erase what I did here so we can talk about it. Remote means not next to. So what angle inside is not next to angle 4? So angle 1 and angle 3 are called remote interior angles. And we should understand that angle 2 would be adjacent because it's next to. We did that in your warm-up problems. And we'll do the next problems in proofs in the next video. Don't want to make it too long for you.